In this video today, I'm going to talk about the lines that intersect circles and tangent properties, okay? So some of these you guys will know. We are now into AKS 7. We're going to examine and apply theorems involving circles, describe and derive arc lengths and area of a sector, model and explain real-life frameworks involving circles. So today we're actually into IOA 7A, which is identify and apply angle relationships formed by chords, tangents, secants, and radii within the circle. And radii is multiple radius. Our objectives today are that by the end of the lesson, you're going to be able to say, I can identify and define circles, radii determine tangents, secants, and chords, and I can use the properties of tangents to solve problems. So a circle is the set of all points in a plane that are equidistant, that means the same distance, from a given point called the center of the circle. So a circle with a center C is called circle C, or that symbol circle C, okay? So again, that means any point on this circle is the same distance away from the center, and we call that the radius, okay? So the interior of a circle is a set of all points inside the circle, no big surprise there. And then the exterior of the circle is a set of all points outside the circle. So obviously the inside here is red and the outside is blue. So the next thing we're going to talk about are radius and a diameter. So the radius of the circle is a segment from the center to a point on the circle. That's this green line right here, okay? A radius can also be described as segments whose endpoints are the center and a point on the circle, okay? Two circles are congruent if they have the same radius. The diameter of a circle is the distance across the circle. So that's this blue line here. It goes all the way across the circle through the center. The diameter is twice the length of the radius because they got a radius right here and a radius right there. So now we're going to talk about some other terms that you may not be as familiar with. Most of you are familiar with a radius and a diameter. So a chord is a segment whose endpoints are on the circle. So a chord, this is a chord right here. And by the way, a diameter is a chord. So this has just got its endpoints on the circle. That's the definition of a chord. And then a secant is a line. Notice this one has points where it intersects the circle, right, at 2 points, but it goes through it. It's a line. And then a tangent line, again, is a line. Remember, chord's a segment, secant's a line, okay? And so this tangent line touches the circle at 1 point, right? So a tangent line is in the same as a plane circle and intersects it at exactly 1 point. The point of tangency is that point where it touches the circle, okay? It's exactly where it intersects the circle. It says example 1 here, identify each line or segment that intersects the circle. So the first thing it's asking us here is for the name of the circle. So the name of the circle is its center. So that's exactly how we're going to say it. So we're going to say it's circle. Let's move that out of the way, L. Or we could use that symbol, that, whoops, I didn't write that, didn't do that very well. It's basically a circle with a dot in the middle of circle C, okay? Then it says radius. Now, in this particular drawing, we have multiple radius, okay? So I'm going to do this in a different color. So we're going from the center to a point on the circle. So we have L, K, L, K, and that's a segment, right? And then we could also call this one right here LJ. There's another one, LJ. And we actually have a third right here, LM, over there. So we had LK right there, we had LJ right there, and we had LM right there. Okay, those are all radius. Thus, they're radii. Okay, now I'm going to go ahead and erase that. We're going to do a different color, and we're going to talk about, let's see if I can use green. Okay, then we're going to talk about the diameter. Okay, a diameter has its endpoints on the circle, right? And it goes through the center of the circle right there. So that is Km, and we only have one of those. And again, Km is a chord because its endpoints are on the circle, but it's also a chord that goes through the center of the circle, okay? Now, there is another chord, and the difference between a chord and a secant is how we name it, okay? So in this particular case especially. So we got a chord right here, Jm, right? See that right there? That's Jm. If its endpoints are on the circle, Jm is a chord, right? We have another one over here, right? Don't we have, isn't Km also a chord? It is. Km is another chord. It just happens to also be the diameter. Now a secant is a line, okay? So I got a line right here. See where the arrows are at the ends? That indicates that it's a line. And the way that we're going to name this differently from the chord that we just talked about, JM, is that it's going to have arrows on either end of it because it's a line, okay? That's the only secant. Remember, a secant is a line that intersects a circle at 2 points. Then we have a tangent, right? So let's see if I can find a different color here. What do we want to use here? Let's just go with orange. How about that? Okay, so this is our tangent line right there. Notice that it only touches the circle at 1 point right there, right? So we're going to call this with that little letter M. So it's going to be line M, okay? And what is the point of tangency? That is that point H, right? So remember, you can name lines with little letters that indicate the line and write the word line, okay? Or you can do it with 2 letters. In this case, we don't have 2 letters on the line, so we have to name it with just that little letter. All right, this is our check it out. Pause the video here and see if you can go ahead and draw these things in the diagram, and then we're going to talk. So the first thing it says here is center Q, so I'm going to label this Q, okay? Then it says radius QR. So I'm just going to draw a radius from the point there to the center. Should be a straight line. Mine's not the best, but you guys get it, QR, right? Then it says diameter ST. So a diameter, remember, does what? It goes through the center of the circle all the way to the other side. It is a chord, but it's a chord that goes through the center. So this is ST. Okay, then we have chord UV. So chord UV is just going to intersect the circle at 2 points. So I'm going to draw it over here. So that's going to be my chord UV. And then we have a secant WX. So secants, remember again, intersect the circle at 2 points. Okay, so we're going to draw that, and it's a line, right? So I'm going to draw it right here. And so this point where it intersects was W. And this point over here was X, okay? And then tangent YZ, let's see if we can find yet another color. Let's see if we can do purple. YZ, okay, so I'm going to do it up here, okay? Now I noticed over here it also says the point of tangency is Y. So we're going to name this Y, and then we're going to do a point on the line that we're going to call Z. So that's going to be YZ right there, and that's my tangent, okay? So our next concept here that we're going to talk about is if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So that means that where the radius, this is our radius right here, intersects our tangent right here, it forms a right angle, okay? So there's always going to be a right angle where a radius intersects a tangent, okay? So then the converse of that is if a line is perpendicular to the radius of a circle, then the line is tangent. So if I do see this right angle here, then I know that this line right there has to be a tangent line, right? So if it is perpendicular, and remember that means that it's a right angle, and perpendicular means that, and we're going to talk about how we can find that in just a second, okay? So it says here, tell whether AB is tangent to circle C, explain your reasoning. Now we just talked about this, right? So if AB is a tangent, there should be a right angle right here because this is our radius, right? So if that's true, then we should be able to use Pythagorean theorem with this, right? So which of these sides is going to be C? It's going to be that side. So what we're going to do is add these two pieces together. So this side right here is going to be 13 because 5 plus 8 is 13. So all we want to do then is do our a squared plus b squared. A squared plus b squared equals c squared, right? So we're going to do 5 squared plus 12 squared. And what we want to see, is that equal to 13 squared? If it is, then it's tangent. Then AB is tangent to the circle. And if it's not, then AB is not. Okay, so this would be 25 plus 144. And then 13 squared is 169, and then 25 plus 144 is 169. So indeed it is equal, isn't it? It is. And so if it is, we can say A, yes. It says, is it, tell whether it is tangent. Yes, AB is tangent to circle C. Okay? So let's see if you guys can do this next one. Come back to me when you're done. Think about where the right angle would be and which of these three sides would be the hypotenuse. Okay, I know that that's the right angle because that's where the radius and the tangent again intersect, right? Okay, so this would have to be my C, right? So that means our other two sides are going to be A and B. So 8 squared plus 16 squared. The question is, does that equal our 20 squared, right? So I'm going to cheat a little bit and look at my sheet because I already did this on my paper. So this is 64 plus 256. And the question again is, does that equal 400? Well, when I add 64 to 256, I don't get 400. I get 320. So 320 does not equal 400. So the answer here is no. AB is not tangent to circle C. Okay, just doing my circle symbol there. Okay. All right, let's see if you guys can do this. You do right here and come back to me when you're done. So here again, we should have a right angle here, right? Because this is a radius and this looks like it's a tangent, right? Doesn't keep going, but it stops there, but that's okay. Okay, so again, this should be side C, right? Because it's opposite the right angle. So we're going to see if 35 squared plus the 12 squared, does that equal 37 squared? Now remember, you guys can go ahead and put this totally in your calculator, right? 35 squared plus 12 squared. When I did 35 squared plus 12 squared, I got 1225 here plus 144. And I got that this was 1369. We're still trying to figure out, is it equal? Add those two together. And yep, that's 1369 equals 1369. So that means ST is tangent to circle P. All right, so this next one, example 3, says AB is tangent to circle C, find the value of R. So now it's telling us it is tangent. So what we're going to do is we'll draw that right angle there. Again, this is going to be our C, right? Okay, so we're going to do 50. Actually, you know what? Let's just do A squared plus B squared equals C squared like we've been doing. So we're going to do 80 squared plus R squared. And now we got to add those two pieces together, right? So isn't that going to be 50 plus R squared? Okay, so 80 squared is 6400 plus R squared. Now you need to remember that this is 50 plus R and 50 plus R, right? So if you need to use your box, do it 50 in R and 50 in R. A lot of y'all tend to make errors with this, so I need to show you why it is what it is. So 55 times 50 is 2500, right? 50 times R is 50R. We got another 50R here, and then R times R is R squared, okay? So we're going to write this in descending order. So we're going to say R squared. Now notice we have like terms right here. You see that 50 plus 50? So that's going to be 100 plus 100R plus our 2500, okay? So I'm going to see what I can simplify now. I can subtract R squared from both sides, because that's going to eliminate my R squareds, right? I can also subtract the 2500 from this side and the other side, right? So now we have 100R equals 6400 minus 2500 was 3900. Got one more step, right? Divide by 100 right here. Okay, so that means R is going to be equal to 39. And we can check this, right? Okay, so this is how we can check it. Put the 39 back there and the 39 back here, right? So now when we check this, this is going to be 80 squared plus 39 squared. And this right here is going to be 89, isn't it? Does that equal our 89 squared? And when you put it in your calculator, it does, okay? So that's our check to make sure we got the right answer. All right, the we do this time, notice that we're missing a different side, okay? So once again, we want to figure out where's the right angle. It is where the radius intersects the tangent, right? So it's going to be right here. That's going to be our C, right? So for this one, we're just going to do 9 squared plus 15 squared, and that's going to be equal to AC squared, okay? So this is 81 plus 225 equals AC squared. Add those two together. I got 306 equals AC squared. Don't forget that you got to take the square root of both sides, right? So take square root here, take the square root here. So AC is equal to 17.49. Depends on how it tells you to round it. Either rounding at 17.49 or 17.5, okay? So I'm going to move this up a little bit so I can work with this last one. Go ahead and pause the video here and see if you can do the next one. So again, we got our radius right here, right? Radius right here, and our tangent right there. So our right angle is going to be here. So that's going to be our C, right? So this time again, we're going to do our 5 squared plus our AB squared, and that's going to be equal to 15 squared, right? So this is 25 plus AB squared equals 225. We're going to subtract the 25 from both sides. So AB squared is going to be equal to the 200, right? And then we're going to take the square root of both sides again. So AB here is going to be equal to 14.14. All right, the next concept we're going to talk about is when we have two tangents that originate at the same point. Okay, so two segments are tangent to a circle from the same external point. Then the two segments are congruent. So we can put a tick mark here and a tick mark here. So say, for example, I told you that this one was 10, then that means that one down there is also 10, okay? So because these are congruent, then as we progress through these problems, we know that AB is going to be congruent to AC. And if we have measures for them, we can set them equal to it, okay? And so that's exactly what we're going to do with these next set of problems. So it says HK and HG are tangents to circle F, okay? So I don't know what's going on there. Find HG. So the first thing I want to say to y'all is we're going to actually do this HK equals HG. So that means we're going to take those equations. HK is 5a minus 32, and we're going to set it equal to 4 plus 2a. So all we want to do here is get our like terms on the same sides of the equal sign, right? So I'm going to subtract the 2a from both sides. This is just algebra, guys. Okay, so this is going to be 3a. Then I'm going to add 32 to both sides because I want to get the constants on the other side too. So that means this is going to be equal to 36, right? Then our next step would be to divide both sides by 3. So a here equals 12. Now here's the deal. It didn't ask me to solve for a. It asked me to solve for HG. So I'm going to solve for HG. HG is the 4 plus the 2 times the 12, right? That's 24 plus 4. So that's going to be equal to 28, right? This equals 28. Now, the way we check this is to see if HK is also 28. So I'm going to do that. HK is going to be equal to 5 times 12. That's 60 minus 32, and that is also 28. So there's my check to make sure I got the right value for A. Okay? So on the we do, again, what can we say? We can say that RS is equal to RT, right? So we're going to set those equations equal to each other. X over 4 is going to be equal to X minus 6.3. Now, I know how much you guys love fractions, so we're going to get rid of that fraction right now. Which, remember, it's being divided, so we're going to multiply this by 4 and all of this over here by 4, okay? So this is going to go away, and this is just going to be x, and 4 times x is 4x, and 4 times negative 6.3, see if I can find my key here where I worked this out, is negative 25.2, okay? Now, if you don't like negatives, you can move this to the other side. which means you would add it. And if you don't care about negatives, then you can just move the 4x. So I'm just going to go ahead and move the 4x because, you know, this might be something that some of y'all might do. So that's going to give me negative 3x here, right? And then this equals negative 25.2. Now, our next step is we're going to divide both sides by a negative, right? 3. So listen, when you divide a negative by a negative, you get a positive. Don't forget that. So x here is equal to 8.4. Once again, this is not the answer to the question. The question's asking us to find RT. So what we're going to do is we're going to plug that value into the equation for RT. So this is going to be 8.4 minus 6.3, and that's going to be equal to 2.1. But we're going to check it, right? So let's check RS because these should be equal. RS is equal to 8.4 divided by 4, and guess what that is? That is our 2.1. So once again, it did check out. All right, let's see if you guys can do these last two. Pause the video here. Come back to me when you're done with both of them. So here again, RS equals RT, right? RS is that n plus 3. RT is 2n minus 1. So I am going to once again subtract my n from both sides. That's now gone, so I have just an n over here, and I'm going to add the 1 to both sides. So n is equal to 4. Once again, not my answer. We're going to plug it into RS. RS is equal to 4 plus 3, that equals 7. And we're going to check it, right, by putting that n into RT as well. So RT is equal to 2 times 4. We all know that's 8 minus 1, and that is our 7 again. There's our check. Okay, if you haven't paused, if you didn't do both of them, pause the video here and go ahead and do the next one. So this one again is AB is going to be equal to AD, right? So we're going to do 2x plus 7 is equal to 5x minus 8. Once again, going to subtract my 2x here and 2x here. That's now gone, right? So I get 3x here, and then I'm going to add 8 to both sides. So now that's gone, and that's equal to 15. Recalling that opposite of multiplication is division, so we're going to divide both sides by our 3 here. So x is equal to 5. Again, not done. We need to find AD, okay? So it says here AD is equal to 5 times 5. That's 25 minus 8. That's 17. You can do that right on your calculator. And then we're going to find AB. AB is going to be equal to 2 times 5. That's 10 plus 7. Yep, that's also 17. So there's our check.